again, I believe this is where we stopped last Thursday. Go back to chapter 6.2. Reminder, 6.2 is very similar to 6.1. The only thing different, and this is what you guys need to tell yourself or ask yourself, which objective do I have, right? And whatever the objective that you have, what are the items that tell me that I need to adjust my standard deviation, right? So remember, you have only two, in chapter 6, you have only two items, which is you have a normal CDF, which is if they actually find the area underneath the curve, if they actually find a proportion of the population, or if they actually find a probability, then that's what you have to do is normal CDF. And in normal CDF, you need the two endpoint and then your mean and your standard deviation, right? And the other thing is the inverse norm, which is if they give you the percentage, which is like C, if they give you the percentage, or if they give you the percentile, or they give you a quartile, then we need to find the actual data or the actual Z-score. Then you have to do the inverse norm. Those are the only two features, or those are the only two items in chapter 6, right? But now in 6.2, what is the difference between 6.2 versus 6.1? 6.2, we are deal with a sample. And if you read this on your homework or on your quizzes or on your test, if you see the word sample, if you see that we have to take some sample out and we need to find the sample mean, if you see the word sample, now you have to say, okay, I'm dealing with a sample, meaning I have to adjust my standard deviation. I cannot use this population standard deviation. I have to adjust this standard deviation to become a sample standard deviation. So this is where the central limit theorem come in, which is, again, looking at this thing here, in 6.2, the first thing we need to do is we need to extract out the mean, and we need to adjust the standard deviation to become a sample standard deviation. How do we adjust that? Well, all we need to do is take the standard deviation, divide by a square root of n, which is, again, a square root of a total sample that we have. So in this case, again, in order for me to find the probability, I need to know the mean and I need to know the standard deviation. It's just that now I'm dealing with a sample, so I have to adjust my standard deviation to become a sample standard deviation. And in terms of this thing here, all I need to do is take a standard deviation, which is 118, divided by square root of 65. So once we have this thing here, we just proceed like before, which is what do? We need to sketch your bell-shaped curve, right? Sketch your normal distribution curve. You know, kind of draw your mountain, put a line through your mountain, and ask yourself, where do I shade it? Do I shade it be on the left of the line, or on the right of the line, or between the two lines, right? So looking at this thing here, I have this less than, right? I'm looking for the probability that a sample score is less than 500. So this is my 500 here, less than. Anything on the left-hand side is less than, which is I shaded on the left. Because once you see this thing here, hopefully you guys say, okay, I shaded to the left, so my lower limit, my lower endpoint have to be some very small number, right? Negative 1 million or 10 million. And then my upper limit will be 500, which is, in this case, we know that we're looking for probability, which is we have to use this normal CDF, which is, again, your lower limit is negative 10 million, and your upper limit is 500, your mean is 514, and your standard deviation, which is, because we deal with a sample, we have to adjust them, which is 118 divided by square root of 65, and you type it out. This is what you should have in terms of your answer. Meaning, again, the probability of this sample, of this 65 people that we have, right, took the test, the probability that the average of this 65 people is less than 500 is 0.1694, or roughly 17%. Okay, so again, that's what they ask you, or this is what we need to do to find this item. And again, similarly to B, this is what you have to ask yourself, is because they ask you in between, which is, again, in between, which is we're looking for the area underneath the curve here, which is in between this item. And again, the only reason why we sketch this thing here is so that we know what is our lower limit and what is our upper limit, right? Which is in this case, my lower limit will be 480. My upper limit will be 520, which is again, all I need to do is put in normal CDF 40, 550, 514, which is your mean, and the adjusted standard deviation, which is 118 divided by square root of 65. And this is what you guys should have in terms of this thing here. So question with A and B here, question of how I got the answer or what you guys need to do or how to determine the difference between 6.1 versus 6.2. All right, so if you don't have that, what is the difference between A and B versus C? Well, C, they don't ask you for probability, right? They don't ask you find the probability or find the area underneath the curve. C, they just ask you in terms of this thing here, they just ask you find the 80th percentile, right? So to find the 80th percentile, reminder, the 80th percentile is basically the same idea in terms that this is the 80th percent, right? Accumulation of the 80th percent, which is again, so this is what we have in the center of this thing here, which is this is the 80% on the left, accumulation from the 0, the 1, the 2, all the way up to the 80%, right? So they basically ask you, if you want to be the 80th percentile, what is the score that you need to score to be the 80th percent? Meaning again, for instance, 79 people or below you, right? So to do this thing here, to know that they give us the percentage, we have to use the inverse norm, right? Because they give us the percentage, we need to use the inverse norm, which is the inverse norm reminder. For my calculator, they only calculate the region on the left, okay? So if you have the 84 that is a little bit more advanced and they ask you, do you want a right hand, the left tail or the right tail or the center, then that's what you have to choose, okay? So for me, because they give me the 80 percentile on the left side, I put 0.80, the mean, which is 514, and the standard deviation, which is the adjusted standard deviation because it's due with a sample mean. So again, 118 divided by a square root of 65. Once I have this, all I need to do is plug in my calculator. And again, if you score, or in this case, if you score 526.3, you are at the 80th percentile, okay? So looking at this thing here, question with this first three problem, any question with A, B, or C, any question in terms of how to type in your calculator or how to know which one to use?
I have a question.
Yes.
Can you show 183 calculator steps for C?
83?
Yes.
So this is the one you have?
Yes.
Okay. So again, for C, this is what you do is, again, you hit second var, which is VARS, and then your inverse norm is option number 3, which is you go down to number 3 and you press enter, right? And then you just type in the way that I have right here, which is, again, you just type in 0.80, comma, 514, comma, 118 divided by square root. Make sure you hit second and the square to have a square root symbol. You hit second and square, which is the square root, and square root of 65, which is, again, once you have this, which is you can close the parenthesis and then press enter, right?
Okay, thank you.
You got it?
Yeah.
All right. Any other question here, ladies and gentlemen? All right. If you don't have questions, same idea go, which is they ask you, would it be unusual, right? Would it be unusual if the sample mean is greater than 550. So again, unusual or usual is the same as basically ask you what is the probability that this sample mean is greater than 550, right? Meaning again, if we take this 65 people took in the test, would it be unusual if the average mean of this 65 people is greater than 550? So looking at this thing here, as always, whenever they ask you for probability or whenever they ask you, try to sketch, right? Try to sketch and see what side are they asking us. And reminder, less than, we do it on the left or we shade it on the left. Greater than, we shade it on the right, which is, this is my greater than item, which is looking at this thing here. If the reason why I ask you to sketch is hopefully with the sketch, it should give you an idea of what is your end point, right? What is your lower end point, which is looking at this thing here. Where do I shade it? The first time I hit this shaded region is 550. And I keep on going to the right, which is what is my highest endpoint I can go. Well, if keep on going to the right, meaning my highest endpoint have to be some big, humongous number. In this case, I use 10 million, which is again 550, comma 10 million, comma 514, and your sample standard deviation. So once you have this thing here, which is again, your answer will be 0.007, which is looking at this thing here, yes, is unusual because the cutoff point is 0.05, which is this number. 0.007 is smaller or less than 0.05, which is, that's why it is unusual. Okay, so again, I think we did this on last Thursday, and this is where I left you guys, which is what is the difference between D versus C, right? And this is what you guys need to know, is if they ask you about a sample mean, if they ask you to find the probability of a sample mean or anything related to sample mean, we have to adjust your standard deviation to become a sample standard deviation by divide by a square root of n. For part E, they just ask you for the individual. They not ask you for the sample, right? They just say, okay, if I have this data, and what is the probability if I go in and pick out one person, what's the probability of this person score greater than, higher than, one individual person score higher than 550? So because we asking for an individual and not a sample, this is in 6.1, which is we just use whatever information they give us, in the sense that all we need to do is, again, our data is the same, which is greater than 550, but the standard deviation we're using is the population standard deviation. We are not dealing with a sample, because this one here, we compare it to every single person. Every single person have the same probability, right? Based on this data. So this is what we have is, again, the probability of me select one person and that person score higher than 550 is this much, is 0.38. So again, 0.38 is bigger than 0.05, which is this thing here is not unusual, right? It's usual, it's you know, it could happen based on this data, it could happen, okay? So looking at this thing here, question, the difference, anybody see the difference between D versus C, or how to determine D versus C in terms of one of them, a sample mean, and the other one is just overall every single people in terms of the population wise. Now, if you don't have question, let's take a look at another problem, which is I have one more problem for 6.2. And hopefully the second time you see this thing here, you can see that it's very redundant. So if you look at this thing here, which is same idea, just different story, right? They give you different story, different data. So look at this thing here, going to work is the name of the question. An ABC News report state that the mean distance that commuter in the United States travel each way to work is 16 miles. Assume that the standard deviation is 8 miles and a sample of 7 commuter is chosen. So we know that they give us some sample, And reminder, the sample that we need is have to be 30 or more, right? Not 30 more than 30. So in this case, our sample is 75, we're good to go. We have the green light, right? Remember, your condition is you either have more than 30 sample or your data itself is normally distributed, right? So looking at this thing here, if you go in and you read this thing here, you see that they say find the probability, normal CDF, that the sample mean, well, sample mean, what does that mean? Hopefully you recognize the sample mean I need to adjust to a sample standard deviation, right? So looking at this thing here, what do I need to do? Well, I need the mean, right? I know I need the mean, which is the mean. The sample mean is the same as the population mean. And I need a sample standard deviation. And in this case, the sample standard deviation is 8 divided by a square root of 75, right? Your standard deviation divided by your square root of your sample, the n. So once I identify that, now all I need to ask myself is, what region do I shade this thing here, right? So looking at this thing here, which is, again, I know that I'm looking for this item, which is, again, 13. And again, just draw your small mountain, right? Bell-shaped curve. And then just put a line through it and ask yourself, do I shade it to the left of that line or to the right of that line? Because it's greater than, anything to the right will be greater than. So why do I sketch this item here? Because if I sketch this thing here, I know that my lower limit will be this number and my upper limit will be some humongous number, right? Something very big, because it keep on going to the right. So again, the upper limit will be something humongous. For us, we use either 1 million or 10 million. And again, it is 100,000 is fine too. You know, I just put 1 million here. So it doesn't matter, it's 1 million or 10 million. You know, after, based on this thing here, after 100, the area is very small. It's not that big. So looking at this thing here, everybody see that my lower limit is 13, my upper limit is 1 million, my mean is 16, and my standard deviation, I need to adjust the standard deviation because of a sample mean. So based on that, this is what I have, which is, once I have this thing here, your calculator will do the rest, which is, again, 0.9994, almost 100%, right? So looking at this thing here, again, you probably say, oh, that's not 99%. 13 should be somewhere around here. But again, your sketching doesn't have to be precise, right? Question with this thing here in terms of what's the keyword we need to looking for, what is the item we need to extract out, and how to convert. And similarly for B, what is the probability the sample mean commute toward is between 18 and 20. So again, between, there's no sugar coated, right? Between, which is, again, you just draw 2 lines and you shade it in between, which is, this is the area I'm looking for, the area in between these 2 regions, this 2 point. So in order to do this thing here, which is, again, this thing here, my lower limit will be my smaller number, my upper limit will be my upper number. And then again, my mean is the same mean before, which is 16, the standard deviation, which is 8, divided by a square root of 75. And once I have this thing here, which is, again, this is what I have, which is 0.0152. And hopefully you guys see the difference between A and B versus C is C, they ask us find the 10th percentile, right? The 10th percentile, what is the 10th percentile? Which is, again, the 10th percentile meaning is 10% to the left of that value. What is this value here? If we only consider 10%, right? So to find that value, or whenever they ask you to do this, is basically you have to do the inverse norm. It's very redundant to the previous one, which is inverse norm. the area to the left, which is 0.10, comma, the mean, which is 16, and the adjusted standard deviation, which is 8 divided by square root of 75, which is, again, if you travel to work 14.82 miles, then you are considered to be a 10% percentile, right? If you travel less than 14.82, then you are below the 10 percentile, okay? So again, that's the idea of this item. Is just that they, hopefully you recognize that they ask you the same thing as in 6.1. It's just that now we deal with a sample. And because we deal with a sample, we have to adjust the standard deviation to become a sample standard deviation. And again, the feature and the function of your calculator is the same, which is the normal CDF and the inverse norm. Question with A, B, or C? Again, D, if you remember the previous problem is very identical, which is would it be unusual for the sample mean distance to be greater than 19, which is again, greater than 19, which is we're looking for this left-hand side. And again, left-hand side, which is the smaller endpoint is 19 and the upper endpoint is some in million, right? So looking at this thing here, we know that the lower endpoint is 19, the upper is a million, and the mean is 16, and the standard deviation is 8 divided by square root of 75. So looking at this thing here, I purposely give you this problem just to make sure, ladies and gentlemen, when you do your homework, if you see this item here, 5.81985 e to the negative 4, this thing here is not bigger than 0.05. When you look at this thing here, you say, wow, 5.8, that's bigger than 0.05. It's not, right? Because of the negative 4, because e to the negative 4 basically tell you to take this decimal, move it 4 places to the left, which is my decimal right here, 5.8, my decimal right here. I need to move it 4 places to the left, which is the actual number is 0.00058. So make sure that you don't just look at this thing here and say, oh, that's bigger than 0.05. The look of the number is bigger, but the actual reality is not, right? You have to move your decimal 4 places, which is, as you can see, this thing here, yes, is unusual because 0.00058 is less than 0.05. So make sure when you see your calculator, make sure that you can read the output correctly. So again, a lot of question on your quizzes, on your homework. For this one here, they probably say yes or no. And again, if you look at this thing here and you jump in and say no because it's bigger than 0.05, you probably be wrong. So make sure that you look at this thing here because it's like e to the negative 4 basically tell you, because negative 4 tell you move 4 places to the left. Okay. So again, everybody see how to translate the scientific notation, scientific in terms of your decimal, so that you can compare the decimal versus the decimal and not the decimal versus the scientific notation. And lastly, if you look at this thing here, similar to the previous one, this thing here we deal with a sample, this one here we deal with a individual, and the individual is basically you compare to the population item. We don't compare to a sample item, so we don't need to adjust the standard deviation. We just use the population standard deviation. So looking at this thing here, which is again, you put in normal CDF 19, and again, the upper limit, which is the only thing different is the standard deviation is a normal population standard deviation and not the adjustment of the convert to a sample standard deviation. So again, 0.3538, which is this thing is larger than 0.05, therefore is not unusual. Based on this thing here is usual for people to go to work within greater than 19 miles. So question with this thing here, question with this problem here, ladies and gentlemen. question of how the problem will look like, or what is the keyword that you need to looking for, or how to adjust your problem. No, not adjust your problem, adjust your standard deviation.
Yeah, I have a question about when we use the in-worm. So like we did number 3 and C and E. So we use the in-worm, and the other one we use normal CDF.
No, for C, we're not using the inverse norm. They not give us a percentage, right? The only time you use the inverse norm if they give you the percentile, like C right here, or they give you the percentage, right? For E, they did not. They just say, can you tell whether it's unusual? Most of the time when you have to determine if it's unusual or not unusual is when you have to find the probability. And the cutoff probability is 0.5. So this thing here, whenever they tell you unusual or usual, you have to use normal CDF.
Okay.
The only time you use inverse norm is when they give you the percentage or the percentile or a quartile, right? So they basically tell you find the value, find the item itself rather than find the probability.
All right, thank you.
So any other question, ladies and gentlemen, before we move to 6.4? Again, we don't have 6.23 as our